Hi, everybody. Yeah, I feel a little bit unusual for two reasons. I was told I'm the only one at the show with a tie, but the other thing is that this is the first presentation of the day that's not about timing. Right? So you can leave now if all you're interested in is timing. But this AES70 comes from the control side of things, and the old one-liner we use in the OCA Alliance is you can send media from A to B, but what are you going to do with it when it gets there? So this is about AES70. AES70's been around for a while, since 2015 or so, and it has roots going way back to 1990 and some earlier other AES work that I was involved in. So I've been working on this stuff for way too long. But so we're about to release another version of AES70. The first version was in 2015. Second version, which is currently available, is in 2018. The third version, which has been published for public comment now, is 2023. And this is just a little bit about what's generally happening. Let's find a little button to push here to get me to the next one. How about that? Does that work? No. This works. Yeah, there we go. So background, this is the outline of the talk. What's AES70? What are the design goals? What standards are in the AES70 family? New features, and some stuff about developer resources, which is an unfolding picture as we go along. AES70 is an architecture for comprehensive control and monitoring of media devices over networks. It's not a media transport protocol. It will not get a signal from A to B. It's not a device implementation framework. It won't tell you what to build inside your device. It's not a user interface specification. That's up to you. It's not an implementation framework for system controllers. It comes out of a technology called OCA. It stands for Open Control Architecture. OCA was the original name, kind of like MADI was the original name for AES10, and eventually, when a bunch of us developed OCA and gave it to the AES for standardization, and it got given the number AES70. So but they're really, you see the logo. This is the logo of an organization called the OCA Alliance that developed the specification originally. It's got AES70 right there. They're really the same thing. Okay, design goals. Industrial strength. The key thing about, there's really one of the big deals about AES70 is designed for professional applications, equipment from many manufacturers, many controllers, networks of all sizes, mission-critical operations, so you can base a life safety paging system on AES70 if you want, and the regulatory agencies will probably approve it. Security is in there. It's modern. There's full support for reconfigurable devices. The AES70 is one of the only protocols around that kind of explicitly, from the beginning, recognizes the idea that there might be software-based devices out there where the controller wants to build the configuration on the fly, dragging and dropping little boxes and connecting with lines, whatever you do. And so AES70 does a good job of supporting that. That's why I say it's ideal for virtualized functions. If you want to do stuff in the cloud, you can control it with AES70 the same as a rack mount device. It's efficient. We have AES70 runs on small micros, smaller than Raspberry Pis. We have a demonstration board of a AES70 running on a little STM micro. I think the chip costs $3. Low use of network bandwidth. It's an efficient protocol. Pleasant and fast to implement. There's lots of predefined functions. You shouldn't have to engineer a lot to implement AES70. A lot of predefined functions that are already there. Various tools available. I'll get into that a little bit later. Small minimum required set of functions. If you want just a little AES70 device that does one thing, you just have to do that. Clean design, no unusual networking requirements. It's just a TCP application. No special switches, no timing, no this, no that. Full support for proprietary extensions. It's product friendly, so if you have something in your product that you do not want to be visible on the network, you don't have to make it visible. Protective of secret device features. You can have a controllable equalizer on the network with a few control functions, but nobody has to see the algorithms that are inside your equalizer. So it's a safe. It's no worse than a front panel of a physical device that way. Stable and available, long service life, It's got lots of engineering for forward and backward compatibility. It's an open, public, license-free standard, costs you nothing to use it, and it's published and maintained by the AES, which is an accredited standards organization. So those are the design goals. This is just a one quick slide. This is too much, don't read it. Just to give you an idea of the repertoire, the functional repertoire of AES70 and the kind of environments that it can operate in. You know, all these little things over there, little function, they're control, the round things are simple control, the round yellow things are simple control functions. The little the pentagons are monitoring functions. The green stuff is grouping type functions. Some of the gray things are overhead and housekeeping functions, and the cyan things down at the bottom are connection management oriented, which I've got a whole, tomorrow at 12:30 over in the AES presentation, I've got like a 1-hour presentation on how AES70 connection management works, in case you're interested, because that's what everybody really sort of gets into control, starting with connection management, and then later they want, oh gosh, I also have to change an equalizer. So, whoops. So yeah, come there tomorrow if you want. But and then there's this little box down at the bottom, proprietary extendability. There's a defined way of extending AES70 to suit your own purposes if you have something special. All kinds of networks, because it's network agile. The current basic definition is for IP networks, but in fact there's another definition. Well, there's some other definitions for other kinds of networks. You can run AES70 over a USB connection if you want to. You have to do a little bit of original work, but you can. Nothing in the architecture that prevents it. All right, now what's published? Here's the AES70 standard suite. They got like SIMT 2110. They got these sub standards. So AES70 1, 2, and 3 are the original core standards of AES70. The first one is about 100 pages. AES70 framework, it defines them. It's a text document, defines the mechanisms and so forth. AES70-2 is the class structure. There's 15 or 20 pages of text, and then a big universal modeling language file to describe the whole repertoire. So all those circles and bubbles that you saw on the slide before are all very rigorously defined in UML, and you can even use them for code generation if you're familiar with using UML for that. AES70-3 is a binary protocol. It's defines what goes along the wire currently, but AES70, the architecture is protocol agile, so you can, although you may have the same device model, you don't have to use exactly the same wire protocol if you don't want to. And in fact, we're working on an alternate protocol definition in JSON that'll be published probably early in the middle of next year, or the first half of next year sometime. And then some other things down at the bottom there, what's called adaptations, where these are customizations, specializations of AES70 for particular purposes, and these two are for connection management. And so the basic core standard has a generalized model, which I'll describe tomorrow, but the model is customized for particular transport protocols. So there's AES70-21 is going to be how to use AES70 to manage AES67 and SIMT 2110 connections. AES70-22, how to use AES70 to manage Milan AVB connections. A little bit more on the status. So current versions, you see the years after the 2018, the 3 standards that are available now, and then the green lane there is what's coming, which are currently out in public comment period. So you can actually go to the AES site right now, download public comment drafts of those green things and read them and comment on them if you want. The yellow stuff is stuff that's going to be released for public comment once the green things are published. The comment period for the green stuff ends up in the middle of November. So from the middle to the end of November, something like that, we'll be dealing with any comments that we received. Historically, there haven't been very many in the previous versions, but maybe it's different now. Anyway, and once those comments are resolved, those green things will be published as formal standards. And once they're published, then the yellow stuff will be released for public comment. And the same process will be, it's a 6-week comment period. And then the red thing, well, we're still developing that, so not sure when. All right, so AES70, how are we doing in time? Yeah, we're doing pretty well. AES70-23, new features. Well, first of all, the new standards that I mentioned, okay? The important blue thing, 2023 will be upward compatible with 2018, we don't violate that rule. There's stuff. Big deal. We got a whole new connection management architecture. It's called CM4. That means we've done it 3 other times, and we think we got it right this time. There's a new networking model that's describe a way that the control commands work with the basic networking that you're using. Whether it's IP parameters and all that kind of stuff. And then there's also a lot of other features. Connection negotiation support is really improved a lot, so that controllers can help devices figure out what compatible stream formats they have in order to talk to each other. Session support is a new thing that allows persistent connections. Certain kinds of redundancy are better supported. Standing multicast, like Milan uses standing multicast that you subscribe to. A session is a persistent relationship between devices that exists, may even survive power up and power down depending on implementation. So that's all in there. That's not all. Another big feature set, large data set storage and retrieval. It turns out there are a lot of times when it was necessary for a controller to send a lot of data back and forth between devices, full configuration uploads and downloads. Imagine a mixing console, thousands of parameters and so on, or other logging files and all this kind of stuff. So we invented a general mechanism for large data set storage and retrieval, and we built in four different versions of it, and you can also do a custom version, but the 4 different versions are media files. So now we have audio file recording and playback, and upload and download, and logging, device logs, command sets and programs. So now we've defined ways you can send a whole bunch of commands up to the device and then execute them later. Or you can do the same thing with binary programs if you want. And then stored parameters is basically just a preset mechanism where you just upload a snapshot, download a snapshot. It's an advanced preset mechanism that allows you to do parts of a device. You don't have to have a complete device preset every time. It's nice that way. And then custom data sets for whatever you want. And then lots of documentation improvements. There's a lot of developer-friendly stuff that we've added. There's lots of 16 informative annexes. Fixed up the language a lot. Really fixed up the UML file to be more self-documenting and clearer. And then a lot of other little things, generalized counter mechanism, better concurrency support, so multiple controllers don't clash. That was always part of the intention, but we've just improved it. A streamlined event notification mechanism makes it easier to implement controllers. Generalized mechanisms for managing sample clocks of internal signal paths. AES70 includes an internal connection model. This is part of the support for reconfigurable devices. Obviously, if you're going to build a DSP device, by dragging and dropping stuff out of a toolbar, you also have to define the signal paths between everything. And now we have much better ways of managing multiply clocked devices, so you can attach different clocks to different signal paths. AES70 has a very flexible clocking mechanism. It can support different time sources, different media clocks, internal, external. That was always there. Now we've applied that to internal clocking in a better way. Better ways of synchronizing device actions to clock time. We've cleaned up the description of external clock sources and so forth, and done even more support for reconfigurable devices, and lots more stuff that's just too detailed to mention. But it really is a lot more usable now than it was, or it's more accessible than it was, and there are fewer questions that people may have. Now, developer resources. Okay, the number of developer resources is slowly growing, and so here's some stuff. The AES OCA Alliance member company, Doiso, you'll see their name of their website a lot. They specialize in AES70 resources, but these are all available. You'll get some links. There's some links at the end where you find this stuff. Well, some links here where you find this stuff too. There's a JavaScript, open source JavaScript library, so this will allow you to build an AES70 controller inside a web browser. There's these 2 commercial libraries, C++ and C# for building devices, controllers, and so on in normal programming development environments. Those are libraries. There are these software tools. AES70 Explorer is a cool thing. It's a generic piece. It's an executable. You know, you run it. You got on your finds all the AES70 devices on your network. Gives you a picture of it. It lets you pick one or two of them. Gives you a palette of controls. You can drag and drop controls out of a toolbar to construct little controllers. It's free, or there's a commercial version that you can use if you want to actually base your own controller on that software. You can also do that too. There's a compliancy test tool that was originally developed by Bosch. Bosch, the company I work for, had a lot to do with the original development of earlier pre-versions of this. So it'll test basic compliance. It won't now. Just to pause for a second, compliancy testing of control protocol is a pretty hard thing to do, because you can certainly test a device to see that it's executing all the protocol operations correctly. But if I tell a device to turn the gain up 5 dB and instead it turns down the panel brightness, I can't test that. You know, you can't really test whether the control operations have the advertised semantics or not, because you know, as I said before, you know, AES70 doesn't dictate how you build your device, just it dictates how it talks on the network. So compliance testing is a complicated question, but the compliance tester will at least tell you if you got the protocol right. There's a Wireshark plugin that decodes this binary protocol that we've got. There's a virtual OCA device for testing controllers. It's a free download, and there's also some online virtual device networks at this website. If you build a controller and want to try it against some online devices, you can. There's what called the micro demo. This is what I alluded to before, that it's a little hardware software design we did that demonstrates that you can run OCA on a really small ST micro. But since that time, that's a few years old. Since that time, I think there's an ESP8286 implementation of OCA right now, and there's Raspberry Pi. So Raspberry Pi is way more powerful than you need for OCA. But you know, the next one is a Bosch OCA reference implementation. That's an older piece that's not free at all. It's a fully engineered implementation. There's products on this floor that are based on a licensed version of that implementation, but and it's still in theory available, but it's being phased out in favor of something we're developing inside the OCA Alliance right now, which is a full open source implementation of OCA that'll be C++ oriented, and it'll be in a repository and have all the right stuff. That will come in 2024. We're already working that out. So those are the tools that now there are a couple of other non-commercial. I don't think I listed here. Yeah. Oh, well, sorry. Let me keep going a little bit. These are hardware software kits. Resolute Audio, by a company called Profusion in England, produces a board and a controller that you can buy and license that implement AES70 and AES67. And this company called Jointed produces a similar thing that implements AES70 in Milan, and you can use that as a proof of concept or as a reference design for hardware or whatever. So those are available, obviously not free. Those are also available. Oh, and then before I should have probably also listed, there are a couple of sort of non-commercial open source projects that are going on right now, which will be listed on the OCA, one of the OCA sites presently. But there's a guy who's in Australia who's implementing OCA. He's a professional programmer, but he's doing this as a hobby project, implementing a version of OCA in Swift, in the Swift language, the Apple development language. And there's another fellow who's a member of one of the member companies here who's got a little nifty thing that's a protocol data unit generator. You can select an OCA command that you want, and it'll give you a hex string of what you're supposed to send down the wire. It's a little developer aid. So those will all be coming up soon. And then here are the links. The main website of OCA is called OCAalliance.com, and that's got all the professional graphics, you know. OCAalliance.com/products shows a list of current products that use AES70. That might be interesting. Then there's OCAalliance.github.io, which we refer to internally as the tech site. And that's a site that a few of us technical types maintain. That's got the downloads and all this kind of stuff. It's not beautiful, but it's where all the developer support is, and so forth. And then the actual AES70 standards are down there at AES.org/publications/standards. That's where you can purchase and download the official AES70 standards documents. So that's it, and yes, let's see. That's a story. I just have a one-line commercial, you know, for you manufacturers out there. Please consider AES70. You know, we believe that AES70 will make time to market go faster. It'll give you, at the same time as that, it'll give you a low-risk strategy for the future because it's a solid piece of engineering, and it'll reduce your engineering costs because it's already done. So fast, good, cheap. And, you know, if you're a manufacturer, I hope you hear that message. So now we have, I think, it looks like we've got about 8 minutes left. Are there any questions?